A very good evening, guys. So, I'm happy to join you on a live session again. So, today we are going to have a very interesting discussion. So, it's about the topic the external and the inner ear. Okay. So, before getting into the session, let us see what we have as a discussion today. Okay. So, let's see the preview. So, today, first, we'll begin with an orientation to the ear. So, we'll have a discussion about the basic structures in the ear. Then we will talk about the external ear in detail, and we'll see the tympanic membrane, internal ear, then embryology a little bit, and finally we'll see what's important for our exams. Okay. All right. So everybody knows that we are all able to hear because the sound that enters the ear is getting converted into some form of an impulse, the electrical impulse. And this electrical impulse then goes to the brain, and in the brain, it is processed, and that's how we perceive sound. Okay, so everybody loves music, everybody is able to hear because of the ear. But have you ever been curious about, have you ever been fascinated by how this sound energy gets converted to an electrical impulse? Because we all know about microphones. That is, it's an artificial instrument which is capable of absorbing the sound energy, and it converts that into an electrical signal. And we can use it for storing, or we can send some message to somebody. But a microphone, we all know that there is a magnetic induction which is functioning there, and that's converting the sound energy into an electrical energy. But what about our ear? Do we have a magnet inside? Definitely not. So what's happening inside the ear? What exactly is converting this sound energy into that electrical impulse, right? It is really interesting, right? So that's what we're going to see today. Okay. So first, before talking about each part of the ear individually, I want you all to have a basic idea of the parts of the ear. So what you're seeing right now in front of your screen is the divisions of ear. So first, you can very well appreciate the two lines. I've marked the two black lines, the slanted lines, to distinguish between the different parts. Okay. So first here is what we have, the external ear. Okay. So in between the external ear and the middle ear, we have a line of demarcation. What is it actually representing? It is representing the tympanic membrane. And what separates the middle ear from the inner ear? It's called the oval window. Okay, the oval window is what separates the middle ear from the inner ear. All right, so that's what we need to know about the parts of the ear. And we might think that it is straight line which is separating the outer ear, the middle ear, and the inner ear. It is definitely not a straight line. It is a slanted line along the line where the tympanic membrane and the oval window are, aligned. So we approximately measure that angle to be some 55 degrees. Okay, right. So let's get into the external ear. So right now I'm going to take you to a travel into the ear, because other structures in the body, many other physical structures, the muscles, you can learn them by palpating on your body, but ear per se, it is quite difficult to palpate except for the external, the outer part. So it's going to be totally an imaginary study. So which means you should listen to each and every word I'm telling you. So as I tell you the story, you just imagine yourself, so that is the only way for understanding this topic. Okay, so we'll begin with external ear. As we start with external ear, just imagine yourself that you are getting into the external ear of some person, and we are going to travel together from the external ear to the middle ear, okay, by crossing the tympanic membrane, and from the middle ear we will enter the inner ear or the internal ear by means of the oval window, and we'll explore what's present inside the inner ear, because inner ear is actually more complicated. Others and all, it'll be like going straight. You'll not have any much complicated structures except for the ones in the inner ear. Okay, so first imagine yourself, you're going to get inside the external ear. First of all, what are the parts of the external ear? What are the parts? So The parts of external ear are the pinna or the auricle. Okay, that's the fan-shaped structure on the outer aspect. Continuous structure from the pinna is called the external auditory or acoustic meatus, right? See, this term is not complicated at all. External auditory meatus. So it's conducting sound, so auditory. Meatus is any natural opening in the body, okay? So it is present externally, we call it external acoustic meatus. So first, let us see about the parts of pinna. Okay, pinna. You can palpate this on your own pinna, or when you're learning in the first time, you can go see someone else's pinna and then you can study from that. For now, just listen to the words, just see where the structures are present. Look at this diagram. Here we are showing the lateral surface of the pinna. Okay. First, there are two surfaces. The lateral surface, okay, the lateral surface is the one which is continuous with the face, okay, on the anterior aspect. And the one which is continuous with the cranium is called the medial surface. So first we are concentrating on the lateral surface. Okay, so the outermost rim of the ear is called as the helix, right? It's called helix. And adjacent to the helix, we have antihelix. So what is helix? I'm highlighting it here. This is helix. Then what is antihelix? It is this part. Okay. And there's another structure on the anterior aspect of helix. What is it called? It's called the crus of helix. Here's it. The crus of helix. Yeah, all right. Okay. Antihelix is also having something like that on the anterior aspect. So the helix is ending up as crus of helix, and antihelix is dividing into two separate elevations. You call them as crura of antihelix. Okay, so now we have seen the helix, antihelix, crus of helix, and the crura of antihelix. Now coming down, we have tragus. Tragus is on the anterior aspect. Opposite to that, we have antitragus. Then in between both, we have the intertragic notch. Okay, the structure which is on the bottommost part of the pinna is called the lobule. The lobule is quite distinct from all because it is the only part where there is fatty tissue, okay? Because the entire ear, that is the pinna of the ear, is made of cartilaginous part. This is something we already know. Except for the part lobule, every other region is formed of cartilage. Okay. Now let us see some fossa or some depressions in this ear. So first we are seeing here the scaphoid fossa on the topmost part, right? It is between the helix and the antihelix. So scaphoid means boat-shaped. Then in between the crura of the antihelix, we have triangular fossa. And the other two cavities or the depressions are concha and symba concha. So what separates concha and symba concha? It is the crus of helix. Okay, you can see that crus of helix is separating the symba concha, which is on superior aspect, and the concha, which is on the inferior aspect. So that's about the parts of the lateral surface. Now let us see the parts of the cranial surface or the medial surface. Okay, the parts are very simple here. We don't have so many parts as we saw on the lateral aspect. So you have only two parts here, eminentia triangularis and eminentia concha. So what is eminentia triangularis? Okay, on the anterior aspect, just try to recollect yourself. We saw the fossa called triangular fossa, and exactly opposite on the medial aspect, it is called eminentia triangularis. Why eminentia? It is an eminence. And eminentia concha, okay, that is just above the symba concha, I mean on the opposite aspect, okay. So that is symba concha on the lateral aspect and eminentia concha on the medial aspect. So now let us see the other features of the pinna. Okay, so let us see about the muscles in the pinna. Okay, it is not a very important topic, just know the muscles because they do not perform any functions, because muscles are important to us to know the functions. Here no muscle is important because they are rudimentary in humans. We would have seen the cats and the dogs, you know, they move their ears. And how do they do that? That's because of these muscles in the pinna. So we are dividing these muscles into two groups, extrinsic muscles and the intrinsic muscles. Extrinsic muscles, which means it is not exactly on the pinna or a part of pinna, but it is extending from outside. Okay. Intrinsic muscles are present within the pinna, which means they are muscular slips between the cartilaginous part. Okay. So the three intrinsic muscles, the three extrinsic muscles are auricularis anterior, auricularis superior, and auricularis posterior, as you can see in this diagram. So the auricularis anterior and superior are having their attachment with the epicranial aponeurosis, and we have the auricularis posterior on the posterior aspect. Just know their locations and that's enough. Okay, their functions are not prominent in humans, except for very rare individuals. Okay. So now we are going to see a very, very important topic. Okay, this is an exam question as well. The nerve supply of pinna, or the nerve supply of auricle. We have two nerve supplies, the motor nerve supply, sensory nerve supply, motor supplying those muscles. So the motor nerve supply, remember, every muscle associated with the pinna is supplied by the facial nerve. So here we are separately dealing with the extrinsic muscles. So look at here, the temporal branch of the facial nerve is supplying the auricularis anterior and superior. Know the names. Okay. Then the posterior auricular branch supplies the auricularis posterior. But however, the sensory supply is more important than the motor supply. So let us see the sensory supply on the diagram. Okay. So first, let's see the lateral surface. Both the lateral and the medial surface, we divide them into three parts. Okay. Concerned with the sensory nerve supply, we divide them into three parts. We have it as lower 1/3, upper 2/3, and between them there is a depression, the concha. And on posterior aspect, we have the, posterior in the sense, the medial aspect, we have eminentia concha. Okay. So first let's see the name of the nerves and then I'll mark it in the diagram. So the lower half is supplied by, lower 1/3 is supplied by the greater auricular nerve. So the greater auricular nerve is supplying the lower half of both, lower 1/3 of both the surfaces, and the concha and eminentia concha both are supplied by the auricular branch of vagus nerve. And now the upper 2/3 is having different supply on the medial aspect and the lateral aspect. So what are those nerves? The auricular temporal nerve is on the lateral aspect, and on the medial aspect the nerve is lesser occipital nerve. Let me show that in this diagram. First we'll start from the lower aspect. The lower 1/3, the nerve that comes is greater auricular nerve. Okay. So from the lower aspect, okay, right. So from the lower aspect, the greater auricular nerve comes. It gives a branch to the posterior aspect. To the lateral. First, it gives a branch to the medial aspect, and then it comes up above. See, the color code for nerve is always yellow, because to show you clearly, I'm using this red color or some dark orange. Okay, so first the greater auricular nerve gives a branch to the medial aspect, and then only it gives a branch to the lateral aspect. It comes above and it supplies the major lower 1/3. Okay, so that's the supply. And then the other nerve above it, which supplies the concha, is the auricular branch of vagus nerve. It will be here in the concha itself. And we have the auriculotemporal nerve, which supplies the upper 2/3. We call that auriculotemporal. Okay. So it's coming from the temporal aspect, supplying the auricle. Okay. So here's how the nerve enters. It comes and supplies the major part, the upper 2/3. And here on the medial aspect also, the greater auricular nerve, as I mentioned before, it comes here to supply the lower 1/3, and the eminentia concha is supplied by the lesser occipital nerve, and on the superior aspect comes the vagus nerve again, the auricular branch, which supplies, the lesser occipital nerve on the upper aspect, which supplies the upper 2/3. Okay, so that's about the nerve supply. Then coming to the arterial supply, venous drainage. So Actually, arterial supply and the venous drainage are not very important. You just know them for a namesake. Okay. You just have to know them for a namesake. It's not very important. So just know what is the particular artery supplying. Okay. So arterial supply is by two arteries, posterior auricular branch of the external carotid artery and the superficial temporal artery. Then the venous drainage is by the corresponding veins. Okay. Now lymphatic drainage is by three group of lymph nodes: pre-auricular, which is the parotid lymph nodes, and mastoid lymph nodes, and then the upper group of the deep cervical lymph nodes. So just know the names. Now coming to the external acoustic meatus. Okay. We mentioned there are two parts in the outer external ear. What we saw first was the pinna or the auricle. Now pinna or auricle is over. Now we are moving inner, okay? Now we are moving deeper. So what we are going to see is the external acoustic meatus, okay? Or the external auditory meatus. So have a look at this diagram. Where is the external acoustic meatus located? Okay, let me mark it here. Yeah. This is the region, okay? This is our external acoustic meatus up to the tympanic membrane. Okay. Now, first let us begin with the parts of the external acoustic meatus. What are the parts of external acoustic meatus? We have it as two parts. The outer cartilaginous part, because we know the pinna is made of majorly it is made of cartilage. So the continuation is going to be the cartilaginous part, outer cartilaginous part, which continues as the inner bony part. Okay. So the approximate length of the eustache, the external acoustic meatus is 24 mm. Okay. And the important thing is, as you can see in the diagram, it appears to be straight, but it is not straight in an adult. Okay. The external acoustic meatus is S-shaped. Okay. It is curved. Why is it curved? If you know the reason, you will not forget it. It is curved because the tympanic membrane is quite protective when it is not a straight route, because we know tympanic membrane is liable to damage by sharp objects. So unless and until it is not straight, the tympanic membrane might be in danger. So for that reason, this is a tube which is curved. It's having an S shape. Okay. All right. So now we'll see about the arterial supply. So just know the names. We don't have a separate diagram for this because again the diagram is not important for it. So just know the names: posterior auricular artery, deep auricular artery, and the anterior tympanic artery. So what are the branches? I mean, these are branches from which main arteries? The posterior is from the external carotid artery, the deep auricular is from first part of the maxillary artery, and the third one, the anterior tympanic, is also from the same first part of maxillary artery. Now coming to the nerve supply. So the nerve supply is by two branches. What are the two branches? The auricular temporal nerve. We saw it in the pinna also, right? The same nerve is supplying here, and the other nerve is auricular branch of vagus. Both of them have been cutaneous supply for the pinna as well. Okay, just correlate with it. Now, what is the exact location which these nerves are supplying? Okay, for that, first, I would like to give one more description about this structure of the external auditory meatus. So this is not a straight tube; it is S-shaped, as I mentioned you. Now, how exactly is it located? So just imagine, so that you can remember it in the right way. Keep your hand like this. Okay, keep your hand like this. What I mean by this is, take it in a three-dimensional view. I'm going upwards, backwards, and medially. Okay, remember it as UBM. I'm going upwards, backwards, and medially. So that is how the first part or the outer cartilaginous part is aligned. Okay, so I'm going upwards, backwards, medially, and then I take a turn. Okay, this tube takes a turn. This acoustic meatus takes a turn, and what happens? It goes downwards, forwards, and medially. Okay, it is DFM. Okay, it is UBM and DFM that you need to remember to know what is the alignment of the canal. So we can imagine that this canal is like a square shaped cavity, so that we have a roof, we have a floor, and we have anterior and posterior walls. So the roof and the anterior wall is supplied by the auriculotemporal nerve. The floor and the posterior wall is by the auricular branch of the vagus nerve. And one very important thing about this external acoustic meatus is the relations. Superior, posterior, inferior, anterior. That's how we have mentioned the relations. What do I mean by this? Again, the same thing. The roof is the superior, the floor is the inferior relation, the anterior and the posterior relations. So, superiorly, we have the middle cranial fossa. Posteriorly, we have the mastoid air cells and the facial nerve. Then, on the inferior aspect, we have the parotid gland. Then, anterior aspect, we have the temporomandibular joint. Okay, let's come to the clinical aspect now. So, in the external acoustic meatus, the two important clinical correlations are, we mentioned 4 walls. On the anterior wall, usually for a baby less than 4 years, in the anterior wall, there's a foramen, the small foramen called the foramen of Hashki. This foramen of Hashki is communicating with the parotid gland. Okay, we say the parotid gland is on the inferior aspect. Okay, so it's communicating with the parotid gland on the inferior aspect, which means there are possibilities of spreading of infections. That's the significance of foramen of Hashki. Okay. The infection may spread from external acoustic meatus to the parotid or from parotid to the external acoustic meatus. And then isthmus. What is isthmus? We know the meaning itself. Isthmus is a narrow connecting part. So, where does the isthmus of the external acoustic meatus comes? We said the tube is, that is the entire tube length can be approximately 24 mm. In this entire length of 24 mm, about 4 mm lateral to the tympanic membrane, there is a very narrow part. Okay. This very narrow part is called the isthmus. Why is it important clinically? Whenever there is accumulation of wax in the external acoustic meatus, we used to remove it. But in case the wax gets accumulated on the medial aspect of the isthmus, that is closer towards the tympanic membrane, it becomes difficult to remove because it is a very narrow cavity. Okay, it's a very narrow part of the canal. That's the significance of isthmus. And on the outer aspect, measuring from the concha, it is about 20 millimeter deeper from the concha. 4 mm lateral to the tympanic membrane, 20 mm deep from the concha. Now let us move on to the next region. Okay, so I said I'll take you to the tour. So we have now traveled through the external auditory meatus, right? Now we have traveled through that S shape, that curved region, and then now, right now, we are right now at the location of the tympanic membrane. Okay, imagine you're standing in front of the tympanic membrane. Okay, you're not taller than tympanic membrane, so you're just staring at it, gazing at it, how the tympanic membrane is actually present. So tympanic membrane is actually a semi-transparent membrane. Okay, so it's a membrane, so obviously it is liable to damage. So which means it is, it's not a strong structure, it's a soft membrane. Now this tympanic membrane, just imagine you're seeing it for yourself in front of you. It's like a concave region. Okay, it's a concave huge door in front of you, which means the convexity is towards the inner aspect, that is towards the middle ear. Okay, now let us appreciate those features later that you can see in this aspect. Before getting into the features, I would just say what is the structure of the tympanic membrane. That is, this huge door of tympanic membrane is made of 3 layers. Okay, it's a very strong one, right? Means it is having 3 layers, but it is not very strong, but it is having 3 layers. So what are the 3 layers? Let's start from outside. It is the outer circular layer, middle fibrous, and the inner mucous layer, right? So that we can appreciate it in this diagram. So first, this outer one is the cuticular layer, the yellow layer. Okay, and the middle one is called the middle one is actually the fibrous layer. Okay, the middle fibrous layer is thickened on the top and the bottom. That is, along the rim, it is thickened to form a ring of the fibrocartilage. Okay, why is this formed? This is formed to attach the middle fibrous layer with the tympanic sulcus on the bone. Okay, now the innermost layer is called the mucous layer. Okay, it's on the side of the middle ear. Now we have also marked two other structures called umbo and handle of malleus. What is umbo? Umbo is the point of maximum convexity. I said you now, the tympanic membrane is in front of you. You're standing in front of it. You're seeing that it is a concave door. So definitely there is some convexity on the other side. So on the other side, if you see, there's one point where the convexity is maximum, which is called umbo. Okay. Now let us see the parts of the tympanic membrane. There are two important parts, the pars tensa and pars flaccida. The major part is formed by the pars tensa. Okay. What are these layers? We just have divided the tympanic membrane into these two layers. Okay. So flaccida is a thinner layer. It's the thinner part of the membrane. Okay. Now, it is enough that you know the names of these two parts. Okay. Flaccida is thin because this middle fibrous layer is not well appreciated in this particular region. That's the reason for the thinness. And one more thing on the inferior aspect, I mean, particularly in the diagram, if you see the pars tensa gets condensed to form the structure called annulus tympanicus. Okay, that's what you see here. Okay, right, that's about the parts. Now let us see about the surfaces of the middle ear. There are two surfaces. Now let's come back to the scenario. You're standing in front of the big door of tympanic membrane. What you're seeing now from the outer aspect, the lateral surface. So let's appreciate the features now. Okay. So on the lateral aspect, the first diagram on the top shows the lateral view. Okay. We divide them into four quadrants. What are the names of the quadrant? The first quadrant is postero-superior, second is antero-superior, third is postero-inferior, and fourth is the antero-inferior. The most important quadrant here is the fourth quadrant or the antero-inferior quadrant. Okay, I'll mention the importance later. Now, what other structures can you appreciate, or what other features can you appreciate? You can see some impressions on this door. Okay, you're seeing the door is huge. You're seeing on your front. On the first quadrant, okay, on this aspect, on the first quadrant, what are you seeing? You are able to see some impression. Okay, a long impression. I'm marking that for the. Okay, I'm marking that on the diagram. It is the long process of incus, which forms an impression. Okay, the long process of incus is on the medial aspect. It forms an impression. You're appreciating that here. The other impression that you could see from a bony prominence is the handle of malleus. Okay. Then we can also appreciate the posterior malleolar fold and the anterior malleolar fold. Both of them are arising from the notch. Okay. This notch is actually formed by one part of the tympanic membrane. Okay. That is actually the location where the lateral process of malleolus can be seen. Okay. You can see the pars flaccida here. Okay, we previously saw in the diagram. It's otherwise called Shrapnel's membrane. And the umbo is actually the midpoint of all the four quadrants. Okay, what is the cone of light that's marked here? It's a clinical significance. The cone of light is seen when you examine the tympanic membrane. How do you examine it? We pass light into the ear, okay, into the external acoustic meatus. So when we pass the light that is reflected from the umbo, okay, that is seen as the cone of light in the antero-inferior quadrant or the fourth quadrant. Okay, that is usually seen in a normal person. Okay, and one more thing I want to mention here. Whenever we do an examination of the ear, especially the external acoustic meatus and the tympanic membrane, we would have noticed the doctors would pull the pinna in a particular manner. What is it? Upwards, laterally, right? Upwards, backwards, and laterally. Why do they do this? The reason is they do this because of the alignment of the external acoustic meatus. We mentioned UBM, right? Upwards, backwards, and medially. So to make the track which is slightly S-shaped to a more straighter one, doctors particularly follow this method to examine. It is upwards, backwards, and laterally. Okay, that's how they do the examination of the external auditory meatus. Now coming to the next diagram, this is the medial aspect. So let us say we have crossed the tympanic membrane, we have entered the middle ear cavity, and now from the middle ear cavity, looking backwards, that is, now say you're turning back, okay, turning back and seeing the medial aspect of the tympanic membrane. What are the features you can appreciate now? We can appreciate the bony prominences showing attachment to the tympanic membrane. So we could see the head of head of malleus. We could see the chorda tympani nerve, which is running between the long process of incus bone and the handle of the malleus. And these are the important features you should appreciate on the medial surface. So that's enough about the surfaces. Now let us see the arterial supply. So we are going to see it as outer surface and inner surface for the entire supply, drainage, etc. So first, on the outer surface, the deep auricular artery supplies outer surface. Inner surface, the anterior tympanic artery and the posterior tympanic artery. Okay. Then venous drainage, it is by the outer surface veins and the inner surface veins. The outer surface veins are draining into the external jugular vein, okay, and the inner surface veins are draining into the transverse sinus and pterygoid venous plexus. Now coming to the nerve supply. On the outer surface, it is the auricular temporal nerve which supplies the anterior half of the outer surface, and the posterior half is supplied by the auricular branch of vagus nerve. Now, inner surface, it is supplied by the tympanic branch of glossopharyngeal nerve. So can you guys say which cranial nerve is the vagus nerve and which cranial nerve is the glossopharyngeal nerve? Okay, so that is about the tympanic membrane. This is a very important question. Tympanic membrane is a repeated short note for you. Okay. Right. Okay. Now we have crossed all those EC areas in this travel. Okay. We have crossed the external ear. Now we, after knowing everything about the external ear, then we entered the middle ear cavity by crossing the tympanic membrane. We saw the features of tympanic membrane. Now we are not going to talk about the middle ear cavity. It is a separate topic. It's a very lengthy topic and it has been previously dealt. So you can watch that video, right? Yeah, very good. 10th cranial nerve is the vagus nerve and 9th is the glossopharyngeal nerve. Okay. So now that we have crossed the tympanic membrane and entered the middle ear cavity, we are going to enter into the inner ear. Okay. So far it was a straight course, almost a straight course. Like we did not have left turn, right turn and all. We just came straight away like the route went. Now getting into the inner ear, it is little complicated because we have so many structures here. Okay. First, before entering this inner ear, I want to introduce you to some important terms. Okay. So that is, I'm going to give you a map. All right. So there are two parts in the inner ear or the internal ear, the membranous labyrinth and bony labyrinth. The bony labyrinth encloses the membranous labyrinth. Okay. So the parts are almost similar. Okay. Bony labyrinth has three parts: cochlea, vestibule, semicircular canals. Then membranous labyrinth has three parts. Actually, it has four parts. Let me show the relevance. The cochlear duct is within the cochlea. The saccule and the article is within the vestibule, and the semicircular ducts are within the semicircular canals. Okay. So that's about the map. Now you know the names, you know the parts, the major parts. Now let me show you how they actually look like. Okay. So let us appreciate the structure. On the left side, you can see the membranous labyrinth. On the right side, you can see the bony labyrinth. So let me show the parts for you. On the upper aspect, what you see is, separate distinction of each part. And on the lower aspect, it is the complete membranous labyrinth. So first, we'll finish off the membranous labyrinth and go to the bony labyrinth. Okay. So what are the four parts we mentioned? The cochlear duct, first part. Cochlear duct. It is a snail-like structure, as you can see in the diagram. Then we have saccule, which is immediately closer to the cochlea. Then we have atricle or utricle. So this is attached to the saccule, and this is a connection between the saccule and the semicircular ducts. Okay, so atricle mainly carries the openings of the semicircular ducts. Okay, so the other one is semicircular duct. So how are they actually aligned? The cochlea is the anterior most structure. Okay, then little posterior saccule, then posteriorly atricle, and more posteriorly we have the semicircular ducts. Okay, so what are semicircular ducts? Semicircular, the name implies it is forming a half circle. Okay, we have three semicircular ducts, namely the anterior or superior semicircular duct, the posterior semicircular duct, this is anterior or superior, this is posterior, and here this is the lateral one. So all the three semicircular ducts are aligned at 90 degrees to each other. Okay, that's one very unique quality of these ducts. Now let us see other parts of this membranous labyrinth. Okay, what connects the cochlea and the saccule? We call that structure as ductus reuniens. Okay, be cautious with the spelling of all these terms. It is not UNIONS, it is UNIENS. Then the structure which connects the saccule and the atricle is called as the articulosaccular duct, and both the saccule and the atricle together form a duct called the ductus endolymphaticus. Okay, it is located downwards, and then the terminal part of the ductus lymphaticus is forming a sac-like structure called saccus endolymphaticus. So the ductus endolymphaticus actually enters through an aqueduct called the aqueduct of vestibule. Okay, now let us see the other structures in the semicircular duct. We said there are openings in the semicircular duct which opens into the atricle. So how many semicircular ducts do we have? Three semicircular ducts. So how many openings should they have? Naturally, we would think it is 6, obviously. Okay, I've just confused you. Wait, there are three semicircular ducts. Three semicircular ducts have two openings each. Okay, which means in total there should be 6 openings into the atricle. Okay, but that is not the scenario. There are only 5 openings. So why is it there are only 5 openings? I'll tell you. So let's imagine every duct is having 2 openings. So every duct has one ampulated opening and a non-ampulated opening. Ampulated means a dilated portion. Okay, so every duct is ampulated and one non-ampulated. Non-ampulated opening, or the end of the anterior or superior and the posterior semicircular ducts together form a common opening. Okay, that is by the structure crus commune. Okay, crus commune is the connection between or the fusion of the non-ampulated part of superior duct and the posterior duct. Okay, so that's crus commune. So there are 6. There should be 6 openings, but there are actually only 5 openings. 3 ducts, 5 openings. Okay, let us see the parts of the bony labyrinth. Bony labyrinth is on the outer aspect. So first we have the semicircular canal here. So except for the name, everything else is the same. Here we have superior canal, posterior canal, lateral canal, and we have the vestibule in the middle. Okay, instead of atricle and saccule, we have a vestibule here. Then we have cochlea. Okay, we'll deal about the cochlea in detail later because that's an important short note. Now we'll see other features about the vestibule and the semicircular canal. Here we'll see about the semicircular ducts. So first, let us see this vestibule. Vestibule on the bony aspect, it has 2 openings, the fenestra vestibuli and fenestra cochleae. Okay, know the names of these openings, right? Then this vestibule has 2 walls, the medial wall and the lateral wall. The medial wall is having, okay, right, the medial wall and the lateral wall are the important parts of the vestibule. On the medial wall, we have 2 parts. Okay, It is particularly called as recess. What is a recess? Recess is like a cavity which holds something. We have an elliptical recess and a round or a spherical recess. So the elliptical recess is what carries the article, and the spherical recess carries the saccule. Okay, so we should know that. All right, so that's about the vestibule. And now talking about the semicircular canal, I'm not going to deal about the functions now, it will be dealt separately in the history. Now just know that the semicircular canal has a structure, the semicircular canal as well as the saccule and arterial have some cells, some structure on them called maculae and crista ampullaris. Maculae, you could see that in this diagram. Maculae is found on the saccule and the article. Okay, what are these cells? Okay, these are cells which are responsible for another function of ear. So, so can you guys remember what is the other function of ear apart from hearing? It has another important function, and I'm sure you all know it. What is the other function apart from hearing? Okay, so see here, there are nerves shown in this picture. We are seeing the cochlear nerve and the vestibular nerve. The cochlear nerve, as the name implies, it is coming from the cochlea. The vestibular nerve is coming from the saccule and the article. Okay, saccule, article, and the semicircular canal. Okay, that is right. So the other function is balancing, equilibrium. Okay, so the balancing is a function which is performed by the semicircular ducts, the saccule, and the article. Okay, semicircular ducts, saccule, and article together perform this function. The cochlea performs the function of hearing. Okay, so just know this, it will be elaborated later in physiology. Now, you just have to know where the macule is located, where the crista is located, and where the organ of corte is located. So, organ of corte is located in the cochlea. So, just know these things, and that's enough. Okay. Now, let us see about the cochlear apparatus. Okay. And by this time, I would also like to mention that the macula is responsible for the static balancing and crista is responsible for kinetic balancing. Okay, this will be dealt later. Now let's see about the cochlear apparatus. Cochlear apparatus means it includes the cochlear duct, which is a part of membranous labyrinth, and cochlea, which is a part of bony labyrinth. What you're seeing right now on the screen is the cross section of the cochlear duct. So before explaining a bit, I would like to talk something about the cochlear structure per se. So cochlea, as we saw in the previous diagrams, we know it is a snail-like structure, right? So it is a snail-like structure, which means it is a coiled one. Actually, the cochlea is a tube, okay? It is a tube which contains 3 compartments or components. Okay, let me show that in this diagram. So the 3 compartments of cochlea are the scala vestibuli, scala media, and the scala tympani. Don't get confused with the words. These are just this might seem confusing for you because it's new, but it is not at all a confusing one. Just know the names now. So these are the 3 compartments of cochlea. So which is the cochlear duct here? Okay, the cochlear duct is this region. Cochlear duct means the membranous labyrinth. This is the cochlear duct. Okay, the outer aspect, that is scala vestibuli and scala tympani, are the parts of bony labyrinth. Okay, right. So actually, just correlate everything that I told you. the membranous labyrinth is enclosed by the bony labyrinth. Okay, so that is how this scala vestibuli and scala tympani are enclosing the cochlear duct, which is otherwise called scala media. Okay, so now this was actually a tube. Okay, this was just a straight tube, but then this has been coiled around a structure called modulus. What is modulus? It is a part of the bony labyrinth. Okay. This modulus is like an axis. Around the axis, this tube is the tube has been rolled around it. Okay, and it has been forming a structure resembling the snail. So that's why we call it cochlea. Now, now that it has been rotated around the modulus, the structure has now been different, right? Now it is having an apex and a base. Okay, the base of the cochlea is what forms the promontory. You would have seen it in the middle ear. We would have seen a structure called promontory. So that is by the base of the cochlea. Okay, right. So I think you would have got an orientation. Can you guys understand how cochlea is having a snail-like structure, that coil is formed? If you cannot understand, I would explain it later. So just say if you have understood how the cochlea is having the snail-like structure. Okay, right. So just see this diagram. What you're seeing right now is the flattened version. Okay, we have uncoiled the cochlea, and what you're seeing is an uncoiled form of the cochlea. Let us explain the parts here. The cochlea, on the top, the scala vestibuli is seen. So you can see the attachment of stapes. The stapes is here. Here's the stapes. So the stapes is having connection with the cochlea by means of a window called oval window. Okay, so the oval window is actually the connection between the middle ear cavity and the inner ear. Okay. So as the vibration comes and hits the stapes, that's how the sound wave is conducted. Okay. The other part that you need to know is helico tremor. What is helico tremor? It is a narrow opening on the apex of the cochlea through which the content of the scala vestibuli communicates with the scala tympani. Talking about the content, what is present in the membranous labyrinth and what is present in the bony labyrinth? The membranous labyrinth, or the scala media, it contains the endolymph, and the bony labyrinth contains the perilymph. Peri means outer aspect, so it is on the outer aspect, so it is the perilymph. Okay. So this endolymph is actually secreted by a group of cells called stria vascularis. I'll show you that in a different diagram. And the perilymph is actually communicating with the CSF, okay, by means of aqueduct of cochlea. Okay. So now what we are going to do is we are going to take a cross section. What sort of a cross section? We are going to take a cross section like this. After unwinding the coil, we are taking a cross section. Okay. So this cross section is showing us this diagram. Okay. So let us appreciate the features in this diagram. Now again, let us repeat. The tube was uncoiled, it was cut, we got a cross section. I mentioned on the top we had vestibuli, bottom we had tympani, and we had the media, scala media in the middle. Okay. What is the important part here? We need to know about the scala media, which is the middle part of the ear, otherwise called as the cochlear duct. Okay. So we are putting this diagram to elaborate about this part. Okay. Right. So let us see what's present inside. First, we'll see the boundaries. There are three important boundaries. What is the roof, what is the floor, and what is the lateral aspect? Roof is formed by the Reissner's membrane, otherwise called vestibular membrane, and the floor is formed by the basilar membrane. Okay. And on the lateral aspect, we have, this is the lateral aspect, we have the osseous spiral lamina. Okay. Now we will see the cells within the scala media or the cochlear duct. So here, attached to the basilar membrane, there are hair cells. What are hair cells? Obviously, these are just hair cells which have these are cells which can show some response with respect to vibration or some movement of the basilar membrane. Okay, so there are two types of hair cells. We have outer and inner hair cells, right? So there is a movement of the hair cells with respect to the movement of the basilar membrane. Okay, now the outer hair cells do not play the important function of converting the signals. Okay, the inner hair cells are the main ones. All these hair cells are having attachment with the tectorial membrane on the top. What is the tectorial membrane? The tectorial membrane is a pink color one which is shown in the diagram. Okay, so the movement or the interaction between the tectorial membrane and the hair cells is what forms the electrical impulses. So this is the crucial part where the sound energy is getting converted into electrical energy. Actually, as it crosses the middle layer itself, the sound energy is getting converted into some form of vibrations which is traveling through the fluid inside the scala vestibuli and scala tympani, and that vibration is transmitted to the hair cells, and the interaction between the tectorial membrane and the hair cells is being shown as the electrical signals. Okay. On the other hand, we have other structures like spiral ligament. Okay. The spiral ligament is what holds the basilar membrane. And we have stria vascularis. I mentioned you before, stria vascularis is what secretes the endolymph, the fluid of membranous labyrinth, or the fluid within this scala media or cochlear duct. Okay. So that's about this cochlear apparatus. Actually, the entire thing that we saw within the cochlear duct, that's called as the organ of cortex, and that's the fundamental part of the inner ear which converts the impulses into sound waves into the impulses. And one more thing, we need to know the innervation, right? You can see the cochlear nerve here. Okay, the cochlear nerve is mainly arising from the inner hair cells. 95% of the cochlear bundle fibers are arising from the inner hair cells and only 5% from the outer hair cells. Okay, so that's the cochlear bundle, right? Now that we have mentioned about the organ of cortei and the cochlear apparatus, we have finished off the entire inner ear, and I would like to show you the 3D visual of the inner ear. Okay, have a look at this so that you will get a good orientation of what we have discussed so far. So here you are seeing the external ear. Okay, first the external ear has the pinna or the auricle on the outer aspect, the palpable one, and this part is the external acoustic meatus, which is the continuation of the external pinna, and then we have the tympanic cavity or the middle ear cavity. So this is the part beyond the tympanic membrane. Okay, right. So what you're seeing right now, the green highlighted portion is called the cochlea. So look at here, the ear is not aligned just like that straight away. See here, this is the temporal bone, and the middle ear cavity lies in the, okay, you're not able to see the video. Okay, okay, are you able to see the picture now? Right, now we'll have some quick questions. So So we are starting from the external ear. What are the two parts of the external ear? You can just type your answers. Okay. What are the two parts of external ear? Then okay. Right. The auricular and the external auditory meatus. Right. After the external auditory meatus, here the white portion. This is the tympanic cavity. Tympanic membrane. Then adjacent tympanic membrane. Here you can see the 3 ear ossicles. How do you remember the ear ossicles? It is MIS, malleus, inus, and stapes. Just see how these bones are aligned. And then we are seeing the cochlea. Okay, we are now getting into the inner ear. Okay. Now in the inner ear, we have cochlea, this green highlighted portion. This is the semicircular canal, and also in between the semicircular canal and the cochlea, we have the saccule and the article. Okay, together they form the vestibule. Right. Can you name the nerve that you are seeing in the screen now? That is, can you name the nerve that is arising from the semicircular ducts, saccule, and the article? What nerve is that? And both these branches of nerves are entering through the temporal bone, so that they form the 8th cranial nerve. Okay, so together they are going to perform two functions. The cochlear nerve, the hearing function, and the other one will perform the sensing function. Right. So on the down below on the left, as a continuation of the middle ear cavity, we have the eustachian tube, which reaches the pharynx. Okay, guys. So that's about the external ear and the internal ear. So we'll see some important questions you have for your exams. Right. And one more thing, embryology will be dealt as a separate topic for you. Okay. Right. So now we'll have a look at the important questions. So here's a list of important questions in the entire topic of ear. So now we have covered these green highlighted ones. Development will be taken as a separate topic. Okay. Right. So middle ear is a 10 mark. Now we have seen cochlear apparatus. We have seen the external acoustic meatus, tympanic membrane. These are very important short notes, repeated ones also. And in very short notes, we have fenestra, vestibule, nerve supply of pinna, which are previous year questions. Okay, so do you guys have any doubt? If you have any doubts, you can put in the comment box. We will review through the comment section. Thank you for taking your time and listening to the session. So yeah, the session of course doesn't end up here. You just have to revise everything, take your book, see everything that I've explained you. Okay, and one small tip, just after you look into the pages, flip the pages, see all those new words for you, write them down, take a list of it, so that next time when you revise the same topic, you will just go through these unknown words. Okay, so that you will retain them longer to keep it in your memory. Okay, thank you.